Hi everyone. In this video we're going to work on some of what I hope is review about graphing quadratics. Let me actually show you this first. This is in the front of your quadratics packet, and this is just sort of a summary of some of the things that I would like you to know. So I would say this might look kind of hectic, but after you've watched videos and worked through some of these, I would just use this to check back through and make sure that the general idea of what's going on here makes sense to you. So I'll try and point back to them as I go so that you can see what I'm hoping for. My big emphasis here is this is kind of a lead up to polynomial functions, so I want to talk a lot and emphasize the fact that there are different ways that you can write quadratic equations, quadratic functions, and the different ways will will show you different information about the graph of the function. So depending on the form that the function is written in, you should get some information for free, and I'd like you to be aware of what that information is and really think about that as you're studying. Okay, so this first one, this is in standard form. So again, I'm going to jump back and forth a little bit. Here we go. Standard form is the first one on this sheet. So we're going to walk through these things, but you can see here that I made a note that this is the one that's easiest to get the y-intercept from. So you should get that for free. And actually, I would say even more than memorizing what you get for free, I think it's important that you understand why you get it for free. So in general, if you want to find the y-intercept of anything, it doesn't matter if it's linear, quadratic, rational, radical, whatever it is, whatever kind of function or equation you're looking at, if you want the y-intercept, you let x equal 0. And if you look at the way this is written, if we let x equal 0, then negative 4 times 0 squared is 0. That's just gone. Negative 2 times 0 is 0. That's just gone. All we will be left with is the 42. So we find out that f of 0 equals 42. That's how you'd write a y-intercept with function notation. Or you can say the point 042 is the y-intercept. I'm going to bug you a little bit here again. I think I bugged you about this in linear. When I ask you for an intercept, I want it to be a point. I want it to have an x and a y coordinate. So even though x is 0 doesn't mean you don't tell me that. And one of the big reasons for that is if we're doing a word problem and I ask you to interpret the y-intercept, it's really important that you get the information about the 0 as well. Okay, so if you are in standard form, ax squared plus bx plus c, the y-intercept should be very obvious. It should be this number right here, and you should be able to spot it even if you forget, because when x is 0, it will wipe out those first two terms. Vertex, there's several ways to go about getting the vertex. I'm going to show you one of them here. Another one will be if it's written in vertex form, the form where we can see transformations, then you should just be able to read off your vertex. And a third one, when you have really nice x-intercepts, the vertex is always in the middle, so we'll hit those as well. But for this one, I would say a good trick to remember for now, when we get to calculus, we have really easy ways to do this. But for now, to find the vertex of a function in standard form, the x-coordinate will always be negative b over 2a. So looking back up at the top, our b is always the number in front of the x. Our a is always the number in front of the x squared. And just to point it out, that 42 is our c. So the x-coordinate of the vertex of this function is negative 2. So 2 over 2a, 2 times negative 4 is negative 8. Which means it's at negative 1/4. Okay, if we want the vertex, we're looking for a point again. So we've got the x-coordinate, negative 1/4. We need the y-coordinate. There's no special formula for this. The function is the formula for this. So if you've got an x-coordinate and you want a y-coordinate of a point on the graph of f of x, just plug that x back in. So f of negative 1/4 is negative 4 times negative 1/4 squared minus 2 times negative 1/4 plus 42. And you can check some of this messy arithmetic on your calculator if you'd like to. I think we could plug through that by hand. But I will point out here, because I think we use calculators a little more heavily in this section, how you would do it. Squared minus 2 times negative 1/4 plus 42, 42 even. Okay. And when I get this, I would much prefer having a fraction. This one's not so bad. 42.775 doesn't have any rounding error, but still you should be able to get it to give you back a fraction just by hitting the math button right below alpha and choosing that very first thing, fraction. And then if you hit enter, it'll turn that into a fraction. So it's 171 over 4, or if you prefer the mixed number, I tend to like the improper fraction, even though it looks kind of messy, because it's really easy to work with if I then need to multiply it by something or divide it by something. But if you prefer, I would be fine as well with 42 3/4. But again, I don't want to see decimals unless you're working on a word problem. Okay, so I got 171 over 4, which is about 42 3/4. So if you want to keep track of that decimal for yourself, that's great, just so that you know exactly where that point is sitting. But I would prefer to see fractions. All right, the last part of this one is to write the function in factored form. So I've mentioned that I'm emphasizing the different forms that you can write quadratics in, and just because you get it in one form doesn't mean it's not easy to put it in one of the other forms. So to write it in factored form, really all I'm saying there is to factor. So if we take f of x equals negative 4x squared minus 2x plus 42, and we want to factor, I think I would first factor out a negative 2. That's looking kind of challenging, but I have a common factor of 2 because I don't really like having a negative in front of the x squared when I factor. That's why I'm deciding to take out a negative 2. Okay, which will leave me with 2x squared plus x minus 21. And I'm hoping I can get further than that, so that is factored, but we're trying to get as factored as possible. So let's split this up. We got a 2x and an x, and I'm going to guess we want the 7 and 3. In fact, I think if I put the 3 here, oh, that's supposed to be 2x. There's 6x. If I put the 7 here, there's 7x. So if it's a positive 7x and a negative 6x, it will add up to my 1x in the middle. Okay, so this is factored form. The big thing about factored form is that it makes it very easy to find your x-intercepts. And again, it's great if you just remember that, but I think even more fundamental than just remembering factored form gives you x-intercepts easily is understanding how you find x-intercepts. So if you want to find x-intercepts, you're going to let y equal 0. So you're going to set the whole thing equal to 0. And this is why factored form is so useful for finding intercepts. If your function factors nicely, then you should just be able to generally read off the intercepts. So we would set 2x plus 7 equal to 0, and I don't need to see this work if you can spot in your head what the answer is going to be. But if you want to work through carefully, if you're worried you're going to make a mistake, we get x equals negative 7 halves. And then from this one, it's looking like x equals 3 will make that 0. So if your quadratic is in factored form, it should be very easy to find the x-intercepts. You shouldn't even really have to do any work a lot of the time. So if you want to do a little scratch work just to be careful, fine. It's also fine with me if you just get right to an answer there. Again, intercepts are points, so I would say my x-intercepts are negative 7 halves, 0, and 3, 0. Okay, this is quite a bit of info, and I don't think I asked it on here, but let's go ahead and make a quick sketch of what this graph looks like. So we know this one crosses the y-axis at, oh, I might want a little more room this way than that. 42, so let's say this is 10, 20, 30, 40. So it's just above that. It has a vertex at really close to that, actually, negative 1/4, 42 3/4. So it's going to be right nearby. After I said I don't usually do mixed numbers, there's a mixed number, 0, 42. And then I know it crosses the x-axis at 3. Let's go 1, 2, 3. And negative 3.5. Okay, so really key thing with graphing quadratics is that vertex is going to be either the very highest or the very lowest point on the graph. So from the vertex right here, I'm going to open down either direction. See if I can make this look kind of nice. Mine looks a little funny. Mine looks a little pointy at the top. It's not pointy. There we go, round it out. The other thing to realize, not only is the vertex going to tell you the highest point, it's also going to give you an axis of symmetry. So if you draw a line right through the vertex, your quadratic should be symmetric across that line. Mine isn't quite perfect, but try and keep that in mind. If yours looks crazy crooked, I might bug you a little bit about that. It's okay to be a little crooked, but try and keep them looking symmetric. Okay, so let me just look back at this list once more and make sure that we've mentioned things we want to. Okay, so again, if you're in standard form, it should be really easy to get the y-intercept. You shouldn't have to do any work to find that. To find the x-intercepts, you're just going to have to set it equal to 0 and do some work. So in this case, it was easy to factor, which gave us our x-intercepts nicely. If it wasn't factorable, you'd use a quadratic formula or you'd square root, something like that. Whatever you need to do to solve the quadratic equation you get when you set that equal to 0. Vertex, in this form, there's two tricks that I'll use, but this is the one we used here. There is this formula, and you just have to remember this for now. When we get to calc, we'll have another way to do it without memorizing that. But for now, negative b over 2a gives you the x-coordinate of your vertex. If you want the y-coordinate, you just plug that back in. So that's what this is saying here. Take whatever you get, plug it back into f. We hit factored form a little bit, so I'll just mention this. This looks really confusing. I would really just say here, don't get too caught up in the way I wrote it. There's all sorts of variations on how something can look when it's factored, so I did my best. But I would say if you can get it factored, it should be easy to find the x-intercepts. And a little vocab here for polynomials in general. There's a few different vocab words that mean the exact same thing. So x-intercepts can be called zeros or roots. That's all the same thing. So I will try not to bounce back and forth between vocab too much, but I probably will do it just because I'm used to using both of those. So zeros, roots, x-intercepts, all the exact same thing. And then I'll save this up. We'll do this one in a little bit. Okay, let's see. I think that's all I've got on this one. Thanks for watching.